All right. Okay, so let's keep going and do some examples. So here's the first one. So we're going to solve this here by factoring. And of course, I forgot to take those out. Well, it's not that big a deal, I guess. I forgot to solve that by factoring. Let me just quickly do this. There we go. It was the red ink from the previous class, so I just took it out. So we want to solve this equation by factoring. Okay, well, notice again, it's already in standard form. That's good. Okay, so to factor this, well, notice that, well, let's try getting the GCF first, okay? I mean, in the previous example, let me actually go back to it. Here, I mean, we could have tried to have gotten the GCF, but it would have been 1. There's a coefficient of 1 and a non-zero constant term. As we have seen before, when that happens, the GCF is going to be 1. So we have a non-zero constant term here, right? A term with no x's. So in our GCF, the smallest exponent of x is 0. So in the GCF, there's no x there. Good. Now for the coefficients in the constant term, as you can see, right? Okay, well, 2 is a factor of 10 and 12. So because of that, the greatest common factor of 2, 10, and 12 has to be 2. So since 2 is the greatest, since 2 is a factor of 10 and 12, and 2 is one of the numbers here, 2 is the greatest common factor of 2, 10, and 12. I hope that made sense. You could always list the factors of each, and you'll see that 2 is the greatest common factor. I think the only common factors would be 1 and 2 among 2, 10, and 12. So the GCF is 2, right? 2m is 0, so 2x to the 0, which is 2. So from there, we factor out the GCF. What do? You put it in front and you divide. And of course, when you divide, that's the same as dividing into each term in the sum. Okay, so here, these 2's are going to cancel. Here, 10 becomes 5. 10 over 2 is just 5, so the 2 here goes away. 12 becomes 6, because 12 over 2 is 6. So what do we get? We get 2 times x squared plus 5x plus 6. That's what we get. Good. So we factor now the trinomial inside. Okay, so we want 2 numbers. So again, notice we have a trinomial, meaning there's 3 terms, and it's degree 2. And the leading coefficient of x, the leading coefficient is 1. So we want 2 numbers whose product is 6 and whose sum is 5. Okay, so 6 we know is 3 times 2. 5 is 3 plus 2. Okay, right? So 3 and 2 are going to work. Again, we want 2 numbers whose product is 6, the constant term, and whose sum is 5, the coefficient of x. Well, 3 and 2 pull that off. So altogether, we get x squared plus 5x plus 6 is x plus 3 times x plus 2. Okay, so when we use that, we have the original quadratic factor. We get 2 times x plus 3 times x plus 2. Now we're going to set each factor equal to 0, like so. Although the 2 equal to 0, well, that's impossible, right? So let's disregard that. And we have x plus 3 equal to 0 and x plus 2 equal to 0. Okay, so from each of those, we're going to get a solution, right? X plus 3 equals 0. Subtract 3 from each side, right? And so x then equals minus 3, right? Because you want to get x all alone. So one solution we get is x equals minus 3. From here, same idea, except instead of 3, you have a 2. So we subtract 2 from both sides. We get x equals minus 2. And that's what we get. Good. Okay. So our two solutions are -3 and -2. And you know, I do a check here and they work. Got it. Okay. So that's how you can solve these with factoring. Are there any questions about this? There we go. All right. So another way to solve these is what's called the quadratic formula. Now, the quadratic formula, okay, again, those give us solutions to this equation. Again, it has to be in standard form, okay? Your quadratic equation has to be in standard form. Otherwise, this formula is not going to help you. And the two solutions to this equation are -b plus the square root of b squared minus 4ac over 2a, -b minus the square root of b squared minus 4ac over 2a. So we have these two solutions, as you can see. Now, what do we do? So these are the two solutions, excuse me. I mean, essentially, you can see that the only difference between them is you have a plus here and you have a minus here. Notice they both have a square root in here. So we are going to have to work with square roots again, right? Again, -b plus the square root of b squared minus 4 times a times c over 2 times a. A cannot be 0 here, so this does make sense. And the only difference here is that we have a minus here. People generally write this more compactly like this, plus or minus, which is nice. You know, it's just a compact notation for the two solutions. Now, also what could happen, as you'll see, is the square root here, the radicand, the b squared minus 4ac, that could be negative. When that happens, there are no real solutions. So for us, there's going to be no solutions because, again, we're only focusing on real number solutions in this class. We're not dealing with complex numbers for time consideration. Okay? But normally, if it was negative, your solutions then could be complex, which can happen. Okay? Which can happen. All right. But again, the equation, the original one, has to be in standard form. Otherwise, this is not going to help us. All right, let's do an example. So let's say we wanted to solve this one using the quadratic formula. Now, it's already in standard form, right? It's equal to 0, equal to 0. So we have a is 3. We have b equals 4. And we have c is minus 4. Okay, so this is what we have here, as you can see. Okay, you know, we have our a, that's always the leading coefficient. B is the coefficient of x. C is the constant term. You have to include the minus sign like I did. And now we can use the quadratic formula. All right. Now, we have minus b plus or minus the square root of b squared minus 4ac over 2a. That's the formula, right? So we have minus 4 plus or minus the square root of 4 squared, right? B is 4. So minus 4 plus or minus square root of 4 squared minus 4 times a, which is 3, times c, which is minus 4, over 2 times a. So in the denominator, we get 6. Here we get negative 4. We have plus or minus the square root of 4 squared is 16. Okay. Notice we have minus minus. If you did the calculation here, you would have 4 times 3 times minus 4. I think that's negative 48. Minus negative 48, that's plus. And we get this. Again, it's normally minus here, subtraction. But we're subtracting a negative number. So we get plus. So we have negative 4 plus or minus the square root of 64 over 6. As you can see. Now what's nice is 64 is a perfect square. So, and the square root of it is 8. So our two solutions are negative 4 plus 8 over 6, which is 4 over 6, which is 2/3. And the other solution is negative 4 minus 8, right? Here we had plus, here we have minus. Negative 4 minus 8 over 6, which is negative 12 over 6, which is negative 2. So we have our two solutions here.